Welcome to Intelligence Gateway. What is data wrangling? Data wrangling typically involves several steps, including 1. Data cleaning. This involves identifying and correcting errors, inconsistencies, and inaccuracies in the data. This can include removing duplicate records, correcting misspellings or typos, and handling missing or incomplete data. 2. Data transformation. This involves converting the data into a format that is more suitable for analysis. This can include merging datasets, splitting columns, or converting data types. 3. Data enrichment. This involves adding additional information to the data to improve its quality, accuracy, and completeness. This can include adding geolocation data, demographic data, or other external data sources. 4. Data formatting. This involves formatting the data in a way that is more easily usable for analysis. This can include standardizing date formats, converting currencies, or reformatting text fields. What is big data? Big data refers to extremely large and complex sets of data that cannot be effectively managed, processed, and analyzed by traditional data processing tools or methods. It typically involves massive amounts of structured, semi-structured, and unstructured data that is generated from a variety of sources, including social media, sensors, mobile devices, and other digital technologies. Big data presents challenges in terms of storage, management, processing, and analysis, and requires specialized technologies and approaches, such as distributed computing, cloud computing, and machine learning algorithms, to extract insights and value from the data. The insights and patterns derived from big data can be used to inform business decisions, improve product development, optimize operations, and enhance customer experience, among other applications. What is Hadoop? Hadoop is an open-source software framework for storing and processing large datasets in a distributed computing environment. It was originally developed by the Apache Software Foundation and is now used by many organizations around the world. The core of the Hadoop framework is the Hadoop Distributed File System, HDFS, which is designed to store large files across multiple machines in a cluster. HDFS is fault-tolerant, meaning that it can continue to function even if some of the machines in the cluster fail. Hadoop also includes the MapReduce programming model, which is used to process and analyze data stored in HDFS. MapReduce works by breaking down a large dataset into smaller, more manageable pieces that can be processed in parallel across multiple machines in the cluster. In addition to HDFS and MapReduce, Hadoop includes a range of other tools and components, such as Hadoop YARN, yet another resource negotiator, which manages resources in a Hadoop cluster, and Hadoop Common, which provides utilities and libraries used by other Hadoop modules. Overall, Hadoop is a powerful and flexible tool for working with large datasets, and is widely used in industries such as finance, healthcare, and e-commerce, among others. What is MapReduce? MapReduce is a programming model and processing framework used for distributed computing of large data sets. It was first introduced by Google and has since become a key component of the Hadoop framework and other big data processing tools. The MapReduce programming model involves two main functions, map and reduce. The map function takes a set of input data and transforms it into a new set of key-value pairs. The reduce function then takes these key-value pairs and aggregates them to produce a smaller set of key-value pairs. MapReduce is designed to work with large data sets that are too big to be processed by a single computer. The data is distributed across a cluster of computers, and each computer processes a portion of the data using the map and reduce functions. What is Apache Spark? Apache Spark is an open-source distributed computing system used for processing large-scale data sets. It is a fast and general-purpose cluster computing system that is designed to be flexible and scalable, making it suitable for a wide range of applications. Spark is built on top of the Hadoop Distributed File System, HDFS, which allows it to leverage the power of distributed computing to process large amounts of data quickly. It includes support for various programming languages, including Java, Scala, Python, and R, which makes it easy for developers to work with. One of the key features of Apache Spark is its ability to perform in-memory data processing, which allows it to process large volumes of data much faster than traditional batch processing systems. It also includes support for various machine learning algorithms, graph processing, and real-time stream processing. Spark has a rich ecosystem of tools and libraries that make it easier for developers to work with, including Spark SQL for working with structured data, Spark Streaming for processing real-time data streams, and Spark MLib for machine learning tasks. Overall, Apache Spark is a powerful tool for working with big data, and it has become an essential component of many modern data processing pipelines. What is NoSQL? NoSQL, which stands for Not Only SQL, is a type of database management system that is designed to handle large and unstructured data sets. Unlike traditional SQL databases, which are based on a relational model that uses tables, columns, and rows to organize and store data, NoSQL databases use a variety of non-relational data models. NoSQL databases are often used in big data applications where traditional databases can struggle to keep up with the volume and variety of data being generated. Some common examples of NoSQL databases include document databases, key-value stores, graph databases, and column family stores. Document databases, such as MongoDB, store data in flexible, JSON-like documents that can vary in structure from one document to the next. Key-value stores, such as Redis, store data as key-value pairs and are optimized for fast reads and writes. Graph databases, such as Neo4j, store data as nodes and edges and are designed for applications that need to model complex relationships between entities. Column family stores, such as Cassandra, store data in tables that are partitioned into columns and rows. What is data modeling? Data modeling is the process of creating a conceptual representation of the data that is used in a particular system or application. It involves identifying the types of data that are needed, how they are related to each other, and how they should be stored and accessed. The goal of data modeling is to create a structure for the data that is consistent, complete, and accurate, and that reflects the requirements of the system or application being built. This is typically done through the use of diagrams and other visual representations that show the relationships between different data elements. There are several different types of data models that can be used for data modeling, including conceptual models, logical models, and physical models. Conceptual models are high-level representations of the data that are used to define the overall structure of the system or application. Logical models are more detailed and describe the relationships between different data elements in more depth. Physical models are even more detailed and specify how the data should be stored and accessed in a particular database or other storage system. What is a data model? A data model is a conceptual representation of data structures, relationships, and constraints that are used to organize and store data in a database or other storage system. It provides a framework for how data should be organized and managed, and helps to ensure that the data is accurate, consistent, and complete. There are several different types of data models that can be used for different purposes. Some of the most common types include 1. Relational data models. These models are based on the relational database model, which uses tables, columns, and rows to organize and store data. 2. Object-oriented data models. These models are based on the object-oriented programming paradigm, which uses objects and classes to represent data and its relationships. 3. NoSQL data models. These models are designed to handle unstructured or semi-structured data, and typically use key-value pairs, documents, or graphs to store and organize data. 4. Hierarchical data models. These models organize data in a tree-like structure, with each level of the tree representing a different category or type of data. Data models are often used by data architects, developers, and other stakeholders to design, develop, and maintain databases and other storage systems. They can help to ensure that data is organized in a way that is efficient, scalable, and easy to use, and can help to avoid data inconsistencies and other issues that can arise when data is poorly organized or managed. What is a data schema? A data schema is a blueprint or structure that defines the organization, format, and relationships of data within a database or other storage system. It specifies the names, types, and constraints of the data elements, as well as the relationships between different data elements. The schema provides a framework for how data is organized and helps to ensure that the data is accurate, consistent, and complete. It is often used by database administrators, developers, and other stakeholders to manage and maintain the database. A data schema typically includes several different components, including 1. Tables. These are the primary objects that store data within the database. Each table represents a different type of data and is made up of a set of columns and rows. 2. Columns. These represent the individual data elements within a table. Each column has a name, data type, and other constraints that define how it can be used. 3. Rows. These represent the individual records or instances of data within a table. Each row contains data for all of the columns within the table. 4. Relationships. These define the connections between different tables and the data within them. Relationships can be one-to-one, one-to-many, or many-to-many, and help to ensure that data is organized and accessed in a consistent and efficient manner. Thanks for watching. For more information, like, comment, and subscribe our channel.